It's me! I'm here! How are you all? I'm hoping that you're all looking forward to learning about some angles in polygons. So there's your title for today. We're going to be learning about what polygons are, how to find the angles inside and outside, and hopefully you're going to leave this lesson knowing more stuff about math than you did when you arrived. So that's the goal for today. There they are, the things that I want you to learn, and we're going to make sure that hopefully we cover everything. And if there's any questions, don't hesitate to use the live chat. Don't hesitate to put, if you're watching this video after the event, then don't hesitate to put messages in the comments below. I'll always try and answer questions if there are any, and try and explain things further. If there is anything, I'll point you in the direction of where you can gain more information. So, polygons. Well, polygons are any shape at all, with multiple sides, because shapes need to have multiple sides. So starting way down with the primitive triangle, all the way up to circles. And circles are considered to be like a polygon, but with an infinite number of sides, because if they're tiny straight lines all the way around, if we then zoom out, it's going to be a circle. But a circle, it has like so many straight lines that it's like one continuous line. So polygons are just the name of all of those shapes. You've got two types. You've got your regular and you've got your irregular. And we're mainly interested in regular because regular has means that all the sides and all the angles are the same length or size. And if you know all the angles are the same size, it allows us to do stuff. If you don't know that, then it doesn't, I guess. So, the polygons themselves. Here they are. Do you know the names of them? Quickly jot down while I'm just saying hello to people in the chat and seeing who's here. Jot down what you think the names of those four shapes are. Hello, Ben. Hello, Alicia. Sto bienem, bueno, si sto bienem, bueno, si. Now, Alicia, your Italian appears to be better than mine. You are good, or you're very good. I think I'm good. You yes. Good morning, Sustings. Hello. I am learning Italian because my wife is half Italian, and so I'm trying to get better. So that's one of the reasons I said ciao, come stai this morning. I'm trying to get better at my Italian and using the time that we're off to try and get a little bit better so I can speak to them in all the family members we've got in other countries. So let's get back to learning. We've got hexagon, octagon, pentagon, and nonagon. I can't say nonagon without doing the song. A nonagon. It all comes from the Latin. The agon bit is of sides or of edges, and then hex is 6, oct is 8, pent is 5, and non is 9. Now, interesting fact, which I always share when I teach this in my class, oct is 8. We know this, right? Octagon, it's 8. And yet October is the 10th month. This is because 2 months, January and February, were inserted. I may have mentioned this in a previous video. Were inserted back in Roman times. It used to have a 10-month calendar, and it used to be a decimal system, and they added 2 more months into the system. So that's why it's now all been shoved forward. So September is the 9th month, but Sept is actually 7. So that's where all that confusion comes from. So a little bit of interesting history for those people who are interested in it, and if you're not interested in it, it's not that interesting history, is it? So, what are we going to talk about? So, we've got the names of the polygons. We now need to do stuff with them. And to do so, I'm going to take you over to my whiteboard. Hello! So, on the whiteboard you can see these 2 questions. By the end of today, we are going to be able to do both those questions. But for now, we're going to ignore them and scroll down to where they can no longer be seen. And I'm fancying starting, I always like to start in black, and then we move on to something more imaginative in a little while. So interior and exterior. If I start with my basic hexagon, then interior angles are just the angles on the inside. I call them int, but interior just means on the inside. That means if I carry the dotted line on, so I carried that line, imagine I'm walking along there and I just carried on straight. That bit there is the exterior angle. The exterior angle is the bit on the outside, but not the whole of the outside. It is just the bit if your line carried on. Now I'd like you to imagine for a minute that I've got a little person who's going to go for a walk around the outside there. Wear a skirt or kilt, might be Scottish. And they're going to walk around the outside and they're going to go that side and they're going to turn that amount of that degrees. Then to there and they're going to turn that much. And then there and turn that much. And there and turn that much. And there and turn that much. And there and turn back. So they're facing the way that they started. In total, they have never faced the same way twice. They were facing up that way, they were facing up that way, they were facing up that way, they were facing down this way, they were facing this way, and then this way. If you've never faced the same way twice, that means there must be a total of 360 degrees exterior angle. Now that isn't the case for all the interior, because if we add all the interior together, it's going to be way more. But for the exterior, it must be a total of 360. And that is the first of our big facts for today. Big fact. You don't have to say that, but it feels quite pleasant. Try it. Big fact for the day. So we've got the exterior angles are always 360, and that's going to be very useful. The second thing some of you may have spotted is if I go here and just colour in that angle there and that angle there, they must make a straight line. And what we already should know about straight lines is that interior... Oh, that's a nice thin one. Didn't even know that existed. You learn something new every day. Must be for handwriting. Interior plus exterior equals 180. That is our second big fact. Again, you don't really need to call it say big fact like I just have, but it is quite fun. So fill your boots. The best small drawing we had was someone managed to draw a bird and a tree inside a hairband, which I thought was pretty impressive. I don't know. I'll share that one. I'll share that with you. It was on the Facebook page. Right. So there's my don't know why I spent so long coloring it. So there's my second big fact of the day. How is this useful? Well, imagine Lars chooses a size shape for us. Lars, do you want to choose a size shape and put it in the chat for us? And we're going to then use that to work out the exterior angles of that shape. We're just waiting for Lars to choose a number. If he doesn't, so absolutely, DJ Games Master, every angle would make 120 on the exterior. But I believe there's actually 6 angles here, not 3. So actually, I think every angle would be 60. We're still waiting for Lars to choose a number, so I might have to choose one. Problem with live chat, people get distracted. I think these are 60, 60, 60, 60, because if the total is 360, we've got 360 divided by 6 angles is 60. And then the interior, you're absolutely right. So you could then work out the interior is 120 because 60 plus 120 makes 180. So we'll go through that in a second. But I was hoping I'm going to come up with a shape. So imagine Lars has just said 8 sides, sir. So if it's 8 sides, we can work out what the exterior angle is by they always total 360. So we're going to take 360 and divide it by 8. And that, I know, is 45. If you're not sure, just use your calculator. 360 divided by 8 equals 45. So there you go. We've got 45, but this is where this bit becomes useful, because as DJ Weaver Games Model, I don't actually know who you are. I know that I know you, and I know that I probably teach you, but I can't remember who you are. That means that 45 plus the interior angle equals 180. So therefore, 45 plus 135. So we now know that the interior angle must equal 135. We were able to find our interior and exterior just by knowing these two angle facts. There is one more angle fact that's interesting though, and it goes a little something like this. Let's imagine I take that shape that Lars definitely told us, and I'm going to make the shape super. It doesn't make nice big shapes. That's a shame, isn't it? I'll have to draw it. So we're going to go 1, 2, 3, 4, 5. We're not going to do that. Oops. It's going to disappear, isn't it? Never mind, this is the problem with doing things live. I meant that to happen anyway. Worst octagon ever. If we want to know the sum of the angles, that's the total. Remember, sum just means total. The sum of the interior angles, then what we can do is we choose one corner and we go to there, to there, to there, to there, to there. Here's one I prepared earlier. You may have seen it in the thumbnail to the video. There you go. I got one corner. I want 1, 1, 1, and I've got 1, 2, 3, 4. In the one I've got just here, I've got 1, 2, 3, 4, 5, 6. That means that there must be 6 lots of whatever the angles in a triangle are. We're all secondary students. I would expect my primary students to know that triangles are 180. So we've got 6 times 180, which is, if James is with us, he'll probably have this answer in his head already. He's quicker than a calculator. 1080. So therefore, we've got 6 times 180, and Lars has finally chosen 7 just when we nearly finished the question. So I will now do a 7 in a second. So we've got 1080 is the total. But if we wanted to find one angle, then we would go, okay, well then we do 1080 divide by, well there's 8 angles. So we go 1080 divide by 8 is 135 degrees. Which I think, if we scroll back up, was what we had when it was 45 degrees earlier. So you can see there's 2 ways to go about this. The reason this is useful, however, is for the third angle fact. If instead of 7, because I think Lars has accidentally clicked the keyboard and he meant to write N, that means we don't know. I'm just checking. If we've got N sides, that means it starts, but we don't know how far it carries on. It could go on any number of sides. The rule is that it is sides minus 2 times 180. This is the number of sides. So that's the total, and that's the third angle fact. There are 3 to memorise, and this is the third one. It's sides minus 2 times 180 is the total sum of all the interior angles. So they are linked. So there's 3 angle facts we've got. The interior angles and the exterior add to 180. The exterior has a total of 360. And then the total sum of all the angles is going to be sides minus 2 times 180. Okay. Well, does that mean we can now have a turn at trying these questions? Well, I hope it does. It needs to come over here, doesn't it? Oh, how have I got over there? I didn't even know that was possible. My screen's bigger than I thought. Let's drag it down. You can amuse yourselves while I'm being painfully slow at using technology. There we go. Thank you for bearing with me. This shape is a regular hexagon. Line BE is a line of symmetry. And it says, calculate the size of angle ABE. ABE is that angle there. The next one says DCE. DCE is that angle there. And the next one says BEC. So it's that angle there. Well, the way I would go about this question is pretty much as I talked about before. If I do that line there and that line there, I can see that this is 2 out of the 4 angles that we need to make there. 1, 2, 3, 4. So the first thing we had to do was a hexagon angle. Some people will remember this already, but if we carry that on, we know that 360 divided by 8 was 45. That tells us that all of this, use a different colour so it stands out, all of that is 135, because the second rule says that 45 plus 135 makes 180. So our final thing is we only want half of that, so we've got 135 divided by 2 is going to be 67.5 degrees. And hopefully you can see everything there. Is there any questions on that? Okay. Thank you very much for DJ Weaver Games Master for explaining that to Willow. Willow, if there's any further questions, do carry on asking. I'm really enjoying this. Okay. That is how we work out that one. DCE can be worked out in exactly the same way. DCE, we got this bit. We know that we only need 1, 2, 3, 4. So if we divide that 135 into 4, we can then times that by 1, because we only want one of them, and times by 1 does nothing. So 135 divided by 4 is 33.75. So you can use this to break the shape up. You find the middle angle and then split it into, these must always be equal, these angles here, once it splits. So that's how you go about doing a question like that. The final one, I'm not even going to do, I left some space for it. Which means, a regular polygon has an exterior angle which is 20 degrees. Calculate the size of its interior angle. Well, we know the rules. Remember the facts. 20 plus something equals 180. Interior plus exterior equals 180. Therefore, that must be 160. How many polygons must it? How many sides must the polygon have? This is working backwards. We know, and Willow was asking about it earlier, why does it take away 2? It's because the number of triangles is always 2 less than the number of sides. 1, 2, 3, 4. It's 2 less than the number of sides. So we know that if sides take away 2 times 180 is equal to 160 the sides, and divide that by the number of sides, is equal to 160. So we have to kind of work it backwards. We therefore know, if we undo this, that the sides take away 2 times 180 is equal to 160 times the number of sides. So I'm going to turn this into an equation. X minus 2 times 180 equals 160. X. Expand our brackets. 180x minus 360 equals 160x. And so we take away and add, so we've now got 20x equals 360, x equals 18. That was quite a long way round. Hopefully some of you spotted, sir, we don't need to do that. The sides in the polygon always make 360 using this rule. We've all learnt this rule today. We could have just done 360 divided by 20 and it would have told us it was 18 sides straight away. Well done those people who spotted you can do it two different ways. I wanted to show you that they'll both give you the same answer. But this is probably the better one to use. The exterior angles always being 360 I think is the easier one to use if you've got a choice. Let's flip back to my PowerPoint for a second. So, today's challenge. I hope I'm not on the screen. Today's challenge is, you've got an Angles in Polygons worksheet which covers all the things that I've talked about in today's lesson. That can be found in the description below. Click show more and it will allow you to click on the link and try the worksheet. I always like to see different people's attempts at stuff, so feel free to take photos, put them in the Facebook group, send me an email with them. Anything you do, and if you've got stuck on anything, the comments underneath this video is a very good place to go. And also, there's a Taskmaster challenge today of make a boat that floats. The instructions are on there. I'd love to see your Taskmaster challenges. Like we had the challenge before with the smallest picture, and I'll try and get some pictures of those ones up. If you want us to add a chance to have a go at those, I need to see your pictures. Okay, so I can only have people entering these Taskmaster challenges. They're a bit of fun if I get pictures. So I've got my email address, and it's all on the following page. Ta-da! Thanks for watching the video. As you can see, I've been working really hard on my English on the time off. So thanks for watching the video. There's all the different things you can do. I hope you've learned something about polygons today. If you have, drop it a like. If you haven't, then let me know what I needed to do still explain. I'll be in the chat for a little bit longer. Hopefully it's made some sense. I'm going to be doing different topics every single week. There'll always be a timetable on the Facebook group telling you what to do. And so you can always request topics as well. I haven't fully planned all my topics for next week. There'll be a Monday, Wednesday, Friday. And so if you've got a specific topic you would like me to cover, just request it. Thank you very much for the congratulations, Ben. I kind of have to thank you because you're one of those 1,000. Thank you very much to everyone for listening to me. I've been Mr. Harris. I'll try and be a bit more sane tomorrow. There's no promises.